All right. Hey, everyone. Welcome to the Optispan Podcast. So I am joined today for the third time by Dr. George Sutphin, a good friend of the podcast. I think you're the most frequent guest so far. So congratulations for that.
All right, thank you. Well, thanks for having me on again.
Yeah. So I thought today, one of the topics that we could talk about are biological age tests. I know you've been doing a lot with your own biomarkers. You've done some of the diagnostics we do here at Optispan. You've done a fair amount on your own. And I believe you've recently done two different biological age tests. And we're talking about the kind of direct-to-consumer marketed tests that people can go online and buy.
Yeah, so we did the Glycan age and the True Diagnostics epigenetic test.
Yeah, and I thought this would be an interesting topic as I just completed my own personal experiment. We just had an episode come out on the results of that experiment where I looked at 4 different epigenetic age tests, did them in duplicate, and then looked at the results. So we can talk about your results. We can talk about my results.
Yeah, because I haven't seen that podcast yet, so I don't know what the answer is yet.
Yeah, it's still a mystery. But one of the things I'd like to get your thoughts on, because I know I have my opinion and I've shared them, but it's good to hear how other scientists think about this, is epigenetic tests in general. I think one question is, how well do they likely measure biological age? Another question is, we can talk about how these things have been developed in the basic research world. And then I think there's a little bit of a disconnect between the way they're used in basic research and the way they're used in direct to consumer. Sure. So I'd like to touch on those two topics at least, and then we can see where the conversation goes. So what are your sort of general thoughts around biological age in general? Do we have the tools to measure it? What are the best tools? And to what extent is epigenetic aging or epigenetic signatures predictive of true biological age?
Yeah, so I overall, I would say I'm optimistic but skeptical of where we are currently. I think the approach is right. If we look at the history of biomarkers, we've been looking for biomarkers of aging as a field since, the 1950s or something like that. And I think the lesson from the early information on that is that no single biomarker is going to give you any meaningful information about your biological.
Right.
It'll give you some information, but not an overall picture of how you're aging.
And maybe just fundamentally, before we get in the weeds, it's useful to kind of define, what do we even mean when we say a biomarker of aging? What would that look like?
So we want some sort of something that's easy to measure at a single time point, or maybe over a course of time, that tells you something about the underlying aging process. So how well are you aging, or to what are you aging more rapidly than the average population is typically how we use these clocks, or more slowly than the average population.
And that can be differentiated from a biomarker of chronological age, right? Which would then really only tell you about how old you are chronologically, how much time you spent on the earth.
Right. And we have a very good biomarker of that, and that's when you were born. Right. So
right.
We're pretty good at measuring that.
But we also have lots of other things that we know change with chronological age.
That's absolutely
right?
true. Yeah.
And so I guess then the question is, how do you differentiate a biomarker of biological aging from a biomarker of chronological aging?
And I think that is the crux of the question about whether the current clocks are doing what they claim to do. Right.
So what would be the key feature, though, that would, if you had the perfect set of biomarkers, that would differentiate those, just so everybody's on the same page?
A marker of chronological age tells you something about where you are in kind of a typical lifespan. Biological age would tell you more about your risk of future lifespan or future death, or how much longer you're going to live from now.
Right. So I think that's one type of definition that people often use. It's a predictor, the way you described it, a pure predictor of mortality. How much remaining lifespan do you have? I'm not saying that's wrong. I think that is one way that people think of these things. A different way, related, would be a predictor of health, which may or may not perfectly correlate with lifespan. And I would argue both of those are correlated with biological age, but not perfectly, right? There are lots of things you and I could do as soon as we walk out of this room that would shorten our lifespan but not accelerate our biological age, right?
And what we're trying to get at is this underlying, the biology of the things that change at the molecular and cellular level during aging. How do we get a metric of how rapidly you're aging at any given point?
Right. Yeah. So this is, I mean, part of the reason why I'm going through this exercise right now is I think this hopefully will illustrate for people. You have two scientists who know more about this topic than 99.9% of the people out there. And it's still a struggle to really formalize what we mean when we talk about measuring biological age.
Absolutely.
I think for me, one of the cleaner definitions is how well your cells, tissues, organs are functioning at the molecular level. But again, that really is a correlation with a lot of this stuff. Certainly that's going to be strongly correlated with health outcomes and longevity. And we can use the hallmarks of aging as a way to maybe measure that.
Yep.
How short are your telomeres? How much have your epigenetics drifted?
Yep.
How are your mitochondria functioning? But given that our understanding of biological aging through the lens of the hallmarks is incomplete, almost by definition, any metric that we make up that measures based on the hallmarks is going to be incomplete. So it's complicated.
And you asked specifically about like an epigenetic clock, right? And that is one hallmark of aging, changes with epigenetics. It certainly has influence and communication with other hallmarks, but it's going to capture a subset of what's changing with age. And then we still don't know if it's measuring, as your question alluded to, whether it's just measuring a chronological age or whether it's measuring something more reflective of the biological aging process under the surface.
Yeah, so I agree completely with the first part of what you said, which is that epigenetics, they're one of the 12 hallmarks. I think at best it's going to be part of biological aging overall, whatever that actually is. One interesting question is, how much? And I tend to be in the same camp that it sounds like you're in, which is they're part of the story, but not everything.
Right. I mean, we don't know all of the hallmarks, almost certainly.
Right. There are people who argue that epigenetic changes are the primal hallmark that drive everything else. I don't think there's very much evidence to support that view other than using things like the Yamanaka factors. You can reprogram cells back to a dedifferentiated state. And in a smallish proportion of the cells that are reprogrammed, they seem to reverse many of the hallmarks and damage that goes along with aging at a molecular level. Most of the cells, or at least a subset of the cells that are reprogrammed, die. So, it's, again, complicated.
Right.
But I think that's the one piece of evidence people would point to, that if we could perfect reversal of epigenetic damage, we might be able to reverse biological aging overall.
Right. And that, to the extent that the differentiation state is aging, I think that could be true, but I that's probably not the whole story either.
The other point that I wanted to make to your comment is, I think that what we have learned is that you can find different epigenetic patterns. So you can find epigenetic patterns that with some degree of accuracy can predict chronological age.
Yep.
That's how the first generation clocks were developed. You can find different epigenetic patterns that with some degree of accuracy predict health or mortality risk. And so the interpretation of that has been that the people whose health predictive signatures or mortality predictive signatures differ from the chronological age prediction are aging slower or faster. So that's kind of the logic behind the idea that there are biological age signatures and there are chronological age signatures. I believe that, with the additional comment that those things like all-cause mortality or risk of cancer or risk of heart disease are only correlated with biological age.
Yeah, I think that would kind of summarize my position on the matter pretty well too.
Cool.
Yeah.
So it sounds like we're both, more or less in the same camp. Yep. If you had to guess, I'll put you on the spot, are epigenetics 90% of biological aging or 10% of biological aging, or pick your own number between 0 and 100?
Oh, I
You
don't
can
know.
be.
I would put it
You don't
more
even
in
have to
the
justify it, but
right. Yeah, I don't know. Maybe somewhere in the 10 to 40% range. If I had to give it the range.
That's a big
So,
range, but
yeah.
I fall in that camp too. But I'm not ruling out the possibility that it's 90%. I just haven't seen anything yet that convinces me. Okay,
Yep.
so that's really important though, because if epigenetics are only 10 to 40% of biological aging, whatever that is, these tests that are being sold to people as biological age tests are at the very best, if they perfectly measured this thing, 10 to 40% of what we're interested in.
Right. And I guess one question I have about these tests is if you do something that we think would slow your aging or extend lifespan, are we seeing the epigenetic age change, or vice versa? If you do an intervention that changes the measured age, is that going to result in a change in lifespan or health down the line?
Right. I think that is fundamentally the important question from a usefulness perspective, right? Are these things actionable? What is your thought on the data that we've got today? What's the answer to that question now?
I don't know. So I don't have like a clear sense of where we are in that ballpark. So okay. I know a little bit. I don't follow this area very close, like extremely closely. So I don't have like a very clear idea of like, are we 60% of the way? Are we 20% of the way to doing that?
Cool. I think that's perfectly fair. I don't know either. My impression is that there's a disconnect between what is out there on the internet and what these companies are implying,
that absolutely
versus what the reality of the research world is. And that's, again, why I think it's really important to talk about these tools as they're used in the research setting differently from the way that they are marketed.
Absolutely.
I think the perception that gets put out there by people who share their biological age results online and some of the companies that market these things is that they are very responsive to lifestyle interventions.
Sure.
I would suggest that is likely to be highly cherry-picked data, although I don't know that for certain. I think the use of these tools in the peer-reviewed literature paints a little bit of a clearer picture that they can be predictive for certain interventions, but they don't really seem to line up with the things that we know of today that significantly improve lifespan and health span in laboratory animals, or at least not perfectly.
Yeah, exactly.
So they don't perfectly recapitulate the interventions that we believe impact the biology of aging based on quantitative data of health span and lifespan.
Yeah, that was my sense, is that it's been a bit mixed. Like some things responded, some don't.
Right. And so I guess the concern would be, again, you understand this, but maybe not everybody watching this video understands this. The concern is when you have a situation like that, many times the successes get amplified and the negative data gets ignored. And so the perception gets built up that these things are working really well.
Yes.
But when you actually, and you see that written in review articles, and then when you actually go look at the data, you're like, that's odd.
Right. And this, I think, the actual data being mixed, I think, is reflective of the fact that we're only the clocks are only capturing a small part of the full picture of aging.
Yeah. So as somebody who's still active in the field, and I mean, like, you're the chair of the American Aging Association, so you've got a position of prominence. What are your thoughts on the way that the term biological aging is being used in the scientific literature? So again, we can't control the way these things are marketed, right? But in the literature, a lot of times we'll see studies where people measure epigenetic age and they'll say X does Y to biological age based on that.
I think it depends on whether a given study is being clear about what they mean by biological age, and whether they're claiming that by changing the clock, they're changing something fundamental about the aging system, which I think the answer there is we don't know. It might be, but making a strong claim about that at this point is not warranted. We don't have a strong evidence. I don't even know if we have a good way to measure whether a clock is actually changing biological age. We don't have validated markers of aging, which is what we're trying to come up with, right?
Right. So, I'm glad you said that. I mean, it's really important. And yet, You see people make claims about biological age in the titles of papers all the time.
Oh yeah, titles are the worst because the journals want sometimes not all the journals, but some journals want the splashier title, and people think they will have a better chance of getting their articles in if they have this big splashy title.
Yeah, I agree completely.
Yeah, titles and abstracts tend to overclaim more than if you actually read through the papers.
Yes. Okay, so let's talk about your experience with these biological age tests. So you did 2.
Yep.
Can you kind of summarize what your experience was like?
The actual experience of taking the test?
Sure. I mean, these are finger sticks.
Yeah,
right?
You have to do the finger stick, and it's not like reading a glucose meter where you need a drop. Especially, I think the Glycan age, you need these 4 big drops. So I think I went through like 12 or 16 of the blood.
Yeah, come on, guys. There's got to be a better way. Yeah. Seriously.
So next time, if you maybe go to LabCorp, we'll let you
ask them for an extra tube.
Yeah, extra tube of blood or something. I don't know if they'll do that, but other than that, the process was pretty smooth. You mail it in, you get your results back. I think
Did you like your results?
They were mixed, so the clocks did not agree.
Let's start with the epigenetic age test.
Sure.
Since that's what we've been talking about. And then we can talk a little bit about what is Glycan age, because it's a different thing that it's measuring.
Yes,
right?
That's right.
A different
that's
biomarker
not an epigenetic clock.
At a molecular level. Okay, so this was true diagnostic. So your summary result is 49.59 ohmic M age.
Not so good.
Your calendar age is 42.34. So that's the chronological age. Okay. So first of all, let's just define a couple of terms here.
Yeah.
Precision and accuracy. Precision is if you did this test multiple times, how close the measured values are to each other.
Right.
But you've only got an N of 1.
Right.
Here. So if this was in the lab, you'd probably tell your student, do the test at least 3 times, triplicate replication.
Absolutely.
Right?
Yeah. You look at this and say, okay, interesting, but we don't believe anything. We can't even do statistics on 1 point.
Right. So there's this question of if you were to take this test with the same sample 3 times, what would the variation look like? We have no information on that.
Right.
Okay. Accuracy is how close is the measured value to the true value.
Right.
The true value is here they're describing it as ohmic M age. So that would be your epigenetic age signature. We don't know that because we don't know what your epigenetic signature looks like other than what they're telling you.
Right.
But the implication is that this is telling you about your biological age.
Right.
We also don't know what your true biological age is.
That's also true.
Going in, it's a little bit hard now because you know the result here. But going in, like, what do you feel like your biological age is? Like, that's probably almost as good as this test.
Right. Probably a little lower than 42, but maybe close to it.
Okay, so
you
feel like you're a little bit healthier than the typical 42-year-old,
right?
And we have
certainly in America. So
and again, that's presumably what this
is based on.
Algorithm is based on. Okay, and we have some data that I think can inform that conversation, right?
Sure.
So you've done your VO2 max twice, one by treadmill, one by bicycle.
That's right.
Where did those come out in terms of percentiles, roughly?
So I bike a lot. I bike commute, so I'm more trained on the bike, and I was in I think the 85th percentile on the bike and closer to 50th for the treadmill, which I used to run, many years ago, but I haven't done a lot of running lately.
Okay.
So,
and we know that VO2 max is highly correlated with all-cause mortality.
Right.
Certainly going to be correlated with overall health status to some extent. A reasonably good thing to think about if we're estimating biological age. So you're at least 50, somewhere between 50 and 85th percentile.
Yep.
That would suggest you're younger biologically based on that biomarker than your chronological age. What about diet? How's your diet look?
Pretty good. We tend to eat a high protein diet is what I've been focusing on recently in an effort to keep lean mass up and lose weight. So I mean, a lot of just whole foods, meats, vegetables, fruits, that sort of thing. So, it's not perfect by any means,
but probably better than average.
Probably better than average.
What about exercise? You exercise regularly?
Yeah. So commute probably 3 to 4 days a week on my bike, and that's about 20 miles total. And then resistance training. I was, 6 months ago, I was at, maybe 2 to 3 days a week, and we got a new puppy, so now it's more like 1 day a week. So,
so it's still exercise regularly.
I'm working more on the Connect pillar now, and it's been
okay. I was going to ask if you have any friends.
Yeah, I got a few friends.
And your sort of stress levels, you feel like you're
no,
okay?
I mean, stress is probably higher than average. So I don't know about average for society, but it's not where I would like it to be. So I prefer that to be lower. So
what
I'm
about
probably
your
on the wrong side.
You sleep okay?
Okay. Not, probably like it depends. Like right now, my sleep is a little worse off than it has been for a while. Again, we have a new puppy.
I feel like I'm your psychologist or something asking all these questions. But I mean, I would say, again, based on those, you're probably middle of the road, but a little better than average, right? Again, kind of lines up with what you said.
Yeah, probably better on the exercise and diet, and then sleep's probably average, and stress is probably.
And this is a useful exercise to go through, as I've sort of talked about on the podcast, looking at the pillars, like where can you get the biggest bang for the buck to prioritize.
Right.
What about body composition? So you got a DEXA. You've had a couple of DEXAs now.
Yeah, so that's been improving. So over the past 2 years, I've come down quite a lot on body fat percentage and come up on lean mass. So both going in the right direction. I'm at about 20% body fat, so like still aiming for.
So for your age, though, that's certainly going to be in the top quartile.
Sure,
of the
I think I'm about 75th percentile. Yeah. Goal is to be like maybe 15%, somewhere in that range.
So that also bone density, okay?
Bone density is I'm about 50th percentile. So.
Any chronic diseases? I shouldn't ask you that, but I'm asking anyway. You have to answer. You can say pass, but any chronic diseases?
No. So nothing. No diabetes. None of those things that have any effect. So.
Okay, so those would all be things that we would think about when we're evaluating somebody's biological age.
Yeah, I'm wearing a CGM, so I monitor that somewhat. And metabolically, my glucose response is pretty good, and I have pretty good like baseline glucose metrics and things like that. Right. So metabolically pretty healthy.
So I mean,
good cholesterol numbers.
Listening to all that, I would guess like if you're 42.3 when you took this test, your biological age is somewhere between 35 and 38, maybe. Sure. I just made that up. But
sure. Yeah.
If I had to guess, right?
Going in with like a feeling about it. Yeah.
Right. So this says you're almost 50.
Right. Yeah.
Okay. So how does that make you feel?
This really is turning into psychological.
I actually think this is important though, right? Because we've already established you don't really believe this is biological age as a whole. You recognize the statistical problems with measuring one measurement, not actually knowing what the precision is of that measurement or the accuracy. So you know the weaknesses in this test, but how does it make you feel?
I mean, I would like it to be lower, if anything.
But why? If you know this means nothing, and I'm not saying it means nothing.
Right. And I don't think it means nothing. I think it's probably telling us something about health.
And why do you believe that? This is a question is a question I'm asking myself. Why do you believe that this test tells you anything about biological age or health? Not epigenetics writ large, not if you were to do this in your lab or if Morgan Levine did it, somebody you trust. Yep. Why do you think this tells you anything about your health?
Well, based on the way they're built, so conceptually they're going across the population and comparing essentially where are you relative to everyone else in this group at your same age group, right? So if that signature on average is a little pushed toward the older, it suggests there might be something there. Again, we don't have really good validated biomarkers to know that, but there's probably something there under the surface. So.
And do you know, is this based on the true diagnostic population?
That I don't know. I don't know which reference population that they're using for this. So that's something that would be helpful too.
And again, I actually like True Diagnostic. I like the folks there. I believe they are trying to do a good job. Sure. Do you have any reason to believe that they use good laboratory practice?
I don't know much about the company, so I don't have any feeling one way or the other going in.
Okay. I'm asking because I think as consumers, we sort of believe some of them, even when we're skeptical of the marketing, we sort of believe that this test is actually a test because they call it a test, that it's a diagnostic tool. Mm-hmm. It is absolutely not.
Well,
it's not CLIA certified.
No, that's for sure.
So I asked because I had the same sort of reaction. Like when I get a result on something like this that's higher than my chronological age, right? Even though I know all the issues,
Yeah.
it's still psychologically, I think, creates some level of anxiety,
Sure.
which is not good. That's not a healthy thing. And so I do wonder about the damage that is done. And maybe some people are motivated by these tests. Like, I think you could be the kind of person where did it motivate you? Did you see this and you're like, 49.59, I'm going to go out and train for a marathon so I can get this down or whatever.
No, I think my skepticism about these things is high enough that it was like, oh, that's interesting. But I don't know if that these tests will have any direct impact on what I do. It's more of something interesting to try, right? So.
Yeah. So anyways, I didn't mean to hammer that so hard, but I do think it's useful to hopefully for people to recognize some of the limitations and maybe if you are feeling anxiety from these tests, think about whether that's a useful thing for you. Okay. Right. So the one cool thing that they're doing now at True Diagnostic is this organ age. Again, subject to all of the same questions around precision and accuracy. So this is, to my understanding, an algorithm that was developed, I think from Morgan's lab, actually out of Yale originally, and now True Diagnostic is applying it. I don't think the paper describing this algorithm has been peer-reviewed and published. I think it's a preprint. I could be wrong about that.
I don't know the answer to
that. But if that's
either.
the case, I guess what I'm wondering is, do you have any concerns with a for-profit company taking a not peer-reviewed and validated algorithm, putting it into a direct-to-consumer product, and giving people this kind of information based on that?
Sure. I mean, we don't.
I guess that was a little bit of a loaded question the way I asked it, but I'm interested to get to hear your thoughts because again, obviously, I do have some concerns about that. I think it's a super compelling and interesting approach.
Sure. Yeah. And without having caveats anywhere in the document, I haven't read through their report in detail about if there are caveats built into this.
Nor probably does anybody,
right?
Or at least most people.
Yeah, and so you and I are in this field, and we understand the limitations of the clock, but most people taking these tests are not, and so that is where I am the most concerned. Is like how are people interpreting this, and how much are they weighing this in their decisions about how to change their health, their lifestyle, and things like that.
Right. Right. So if we just look at this, your lungs look really good.
All right.
Your blood, not so good.
Not so good.
Liver, inflammation, good. Kidney, heart, hormone, immune system, not so good. George.
You sound so disappointed, Matt.
I guess one question would be to the extent that you can conclude anything from this, does that line up at all with your perception of your organ health prior to taking the test?
I don't know if I think necessarily have a strong opinion on my kidney health versus my lung health.
Does it line up with other biomarkers that you've looked at all?
I mean, I've had kidney diagnostic blood work, and those are always just about in the middle of the normal range, I think. So, okay. I guess one question I have is how responsive are these to short-term stress sort of response? Yeah,
great question. I don't know that we know. They may know the answer to this. Yeah. I don't know that we know the answer to this. Again, my perception, mostly from what I have heard, not so much what's in the peer-reviewed literature, is that some people see quite rapid changes in these tests in response to maybe lifestyle changes. But I think the question is, given that we don't know what the variance is, if you did the same test twice on the same day, actually we do now. I can show you that data.
All right.
But are these rapid changes just noise, or are they real changes in response to lifestyle changes? I don't think we know that yet.
One thing I have not told you about this test is I had a pretty significant health stress about a week before this.
Oh, interesting.
So we had a friend of mine and I went into the Grand Canyon for a long hike. And we'd done our research and we'd kind of looked for water sources and all that things, but we got to our first campsite and both our primary water source and our backup water source were completely dry.
Oh my God.
On top of that, my hiking buddy had a knee injury that started acting up, so he was moving slow. So we ended up actually having to be rescued.
Wow.
And by the time we had basically out of water by the time they got there. So we were both fairly dehydrated by the time we got out of the canyon.
Interesting.
And that was about a week before this event happened. And so, or this test, I took this test, so that I was wondering if there's any residual like short-term effects on the test from that. And as you say, we don't know, but how does anything you're doing in your life affect these things?
Super interesting. And again, I think there's a couple of things that are worth double clicking on there. One is the question you asked, like, might that have influenced the result that you got? I think we are often tempted. So we are often tempted to put aside all of the things that we've just talked about as to why you probably can't trust this one measurement and put any confidence in it. And then try to rationalize it, despite the fact that we know you can't trust this one measurement based on what might have happened, right?
Yeah. Right, exactly.
So how would you test that? So if you wanted to know the answer, how would you test that? Sorry, I know I'm treating you like a graduate student. You were a graduate student with me decades ago, so
you haven't broken the habit yet. So.
But how? I mean, really, what would the experiment be if you're like, I wonder if that caused me to get a bad result on this test?
Ideally, under any circumstance, you wouldn't just take one test. You would take multiple tests, and that would be well beyond the stress event. Now, would I want to repeat the stress event and see if
right.
I don't know if that's the right answer.
You could at least do technical replicates, though, right? You could do the test right after the stress event 3 times, and then 3 months later 3 times, and see what does that look like. The problem is that would run you. I think these are like $400 each. Yeah. It gets expensive really quick. But that's what you'd want to do. Right?
From the research end of this, like if we're doing clinical testing of this, doing something like that would be a much a better approach. Right?
Yeah. And again, this is the problem with trying to use these direct-to-consumer tests, especially the influencers who are out there, making claims based on their test result.
Yeah.
They're only measuring it once. They may not even be showing you the results they don't want you to see. I don't think you can conclude anything from that.
And if you want to test a stress event, there are ways to do that clinically as well. If you have somebody come in who's dehydrated, you can then offer them, like, we're going to run this clinical test on you. Are you willing to sign up? And then you could get a cohort of people and see if there is a difference.
Right. Okay. So in the good news bucket, your Dunedin PACE score is 0.82, which means despite the fact that you are biologically older than your chronological age, you are aging more slowly than the average person in the population. So congratulations on that.
Does that mean wild youth is caused me to age faster, and now I'm doing well and aging more slowly, something like that?
Maybe. Yeah. Again, we could come up with all sorts of possible explanations.
How wildly can I interpret this stuff? So.
Again, I think the same limitations, one measurement, no information about accuracy or precision. This is the metric that you see talked about a lot. This is what the Rejuvenation Olympics is using. Again, if you were to do this same test 3 times with the same sample or 3 times over a 3-month period, what would the variation look like? I don't think we know. But so you get a little bit of good news, a little bit of bad news. Yeah. You walk away feeling, I don't know, how do you feel?
About the same.
Okay, good. So we've covered epigenetic age, and epigenetic age is really only one of the types of molecular information that you could look at to assess biological age. And so maybe it's worth just, before we talk about the other tests that you took, it's worth just talking about what are some of the other types of biomarkers you might use if you wanted to develop a biological age test.
Sure. So I know in mouse work we use, for example, a more of a physiological test like frailty index, where you measure a whole bunch of things like how gray is the fur and how hunched is their posture, and how rapidly can they flip if you flip them over. So a bunch of just small things that add up that give you a pretty consistent look at the overall animal health. You can look at those individually, but then what really helps is like with a clock, you combine them all into one score, and that gives you some sense of how healthy the animal is. So I like the physiological ones because that's telling you a little bit closer to what we care about is like health function.
Right. So functionally, how well is that individual or animal doing?
Right. But there are other molecular things. You could take a blood test and do a combined marker on kind of any set of things you wanted to look at. But the other one we looked at here was this Glycan age test, which is another one that I think you noted has gotten some traction in the field and looks at kind of sugar groups attached to proteins in the blood. And that changes with age, and it just gives you a different perspective to look at the potential aging process through a different set of molecular changes. So it should be maybe somewhat orthogonal to epigenetic age. They're going to talk to each other to some degree, of course. But.
Yeah. So my understanding of the glycan biology is that there are multiple different types of these glycans that chemically, structurally are distinct. And I believe by mass spectrometry, you can quantify the relative amounts of these different glycan species. And then much like was done with epigenetic marks, people have identified correlative relationships between certain glycan species and chronological age or mortality or specific disease incidences.
And like epigenetics, you capture a set of these that set has been found to correlate well. And so you use them as a combined metric of age.
Right. And maybe just to give people a feel for where the biological age testing could be going. Again, so we've got epigenetics, which are chemical modifications, methylation primarily on top of DNA. We've got glycans, which are sugar moieties attached to proteins in blood. You could, in principle, look at RNA transcriptomics, and people do that. There are transcriptome clocks. You can
Absolutely.
look at proteins, proteomics. There are protein clocks. You can look at metabolomics. There are metabolite clocks. You can look at almost any sufficiently high-dimensional type of data, and if it changes with age, potentially find a signature that is correlated, a subset of the features that are correlated with chronological age, and then in principle find a different subset that are correlated with biological outcomes.
Right. And most of these, because blood is easy to collect, are measured in blood, but you could also look at urine or tissue samples or something like that. And perhaps looking at multiple of these different sets of biomarkers in combination will give you a better answer than looking at any one of them on its own.
Yeah, I think that's a really, really good point. And in fact, of the 4 epigenetic tests that I did, I think 2 were saliva and 2 were blood.
Oh, okay.
And one of the companies, I believe, even offers you can do it in urine or blood. So yeah, so you're right. Other biological sample types should have signatures, same types of signatures, different signatures that will correlate.
Yeah. And microbiome is another one I'm
right. Yeah, good point. At, so. Yeah. And I think people are starting to build microbiome aging clocks.
Absolutely.
So all of these are susceptible to the same opportunities and challenges as the epigenetic clocks.
Right.
And, it's an interesting question. Why are the epigenetic clocks so favored at this point over these others? Is it just that they haven't been studied as much, or is there some more biologically fundamental reason? Or is it just they cost less?
Oh, yeah. And I think they were the first to do these high-dimensional clocks. At least they were the most prominent early ones, I think is what happened. I don't know if they were the very first ones.
Yeah. I don't know either, although I do know people previously had built crude clocks based on like telomere length.
Sure.
The issue there is, of course, the technology for measuring telomere length wasn't, and to some extent still isn't, that great. And the cost is high. So I think it's probably a combination of all these things that determine which gets used most in the research world and which gets moved out into the marketplace and the direct-to-consumer market in particular.
With respect to the telomere clocks, were those multi-point clocks in some sense? What was the multi-point? Was it
I think people
tissues?
have done both. I think the first really early crude versions were just average telomere lengths, and then people started trying to look at the distribution of telomere lengths. And then, I'm maybe misremembering exactly the things that were included, but I do remember this was back, I think, when I was a graduate student, like a combination of telomere length with DHEAS and maybe a couple of other hormones, as predictive of all-cause mortality. So this process to get where we're at today has been going on, as you alluded to earlier, for decades.
Right.
And we look back and we're like, oh man, that was really crude, what we were doing in the 80s or 90s. But I suspect 20 years from now, we'll look back and we'll be like, oh man, epigenetic clocks, what the hell were they thinking? So it will continue to evolve and get more precise.
Sure.
And again, my feeling is, and I think this is true with the glycan age as well, What we don't have yet is the clear mechanistic connection where we can say this epigenetic mark is mechanistically driving this disease or this all-cause mortality, or whatever the outcome is that we're correlating these things with. And so that leads to a lot of uncertainty about what these things actually mean.
Yeah, if you could have that direct molecular chain, like the causal events, then I would have a lot more confidence in the metrics being relevant. Yeah.
Right. Okay. So you get your report back. October 7th, 2024 is the date of the test.
Yep.
So maybe it's worth saying that these glycans, this is my understanding of the literature, and this is the way the company presents it, are thought to particularly reflect inflammation or inflammaging, right? The increase in chronic inflammation that goes along with aging. Certainly they reflect other things, but that's one of the things that they point to, is that the glycans are responsive or telling you something about your inflammaging. Okay, so your, is this right? Your biological age by this is 21?
Yeah, that's right.
Congratulations, you can drink, George.
So, yeah. I'm 50 and I'm 21.
Wow.
All right.
So I have some bad news for you. It's my understanding that, and again, I'm sure that the people at Glycan Age, Nina, will let me know if I'm wrong on this, but it's my understanding that baseline glycans are largely genetically determined. So the initial age, I'm not sure quite why it's presented this way. Again, if I'm wrong, please let me know. I'm not 100% certain of this, but it's my perception, my understanding that the initial age is less informative than the change over time.
Okay.
So it might be the case that you're really biologically 21. I would love to believe that. But it might also be that you just happen to have a genetic makeup where your baseline glycan signature is at a lower age. Sure. And what really matters going forward is how it changes. This is what I've been told. I don't know for sure what the science says. Okay. So really that's great. How did that make you feel, George? Did you feel 21?
Yeah, right out of the bate. Yeah. Well, you met me around when I was a little older than 21.
Probably, yeah.
So I haven't aged at all, have I?
You haven't aged today.
All right.
Although you didn't have that beard when I first met you, I don't think.
Oh, yeah, it was fully gray at that point, too. So,
and then you get some other information about different species, which we don't need to go into. Your anti-inflammatory glycan shield, that's a cool name, looks pretty good. So this would suggest that your inflammatory state, if we accept, again, this is susceptible to all of the same limitations that we picked up on related to the epigenetic test, right? One measurement, we don't know anything about precision. If you were to do this same test 3 times, would you get 21, 42, and 86? Like, we don't know. And accuracy, how accurately is this measuring your glycan age or your biological age? We also don't have a lot of information about that.
Have you taken this one again twice on the same day like you did with the other
haven't.
ones?
So I did not do the glycan age as part of that others, because I felt like I want to do an apples to apples epigenetic test. Would be interesting and informative. I do have longitudinal data on glycan age. I have to go back and look at it. My recollection is that my glycan age, it's not as good as yours, but it tends to be in the 30s, and that's held up over time. So again, that might mean that I'm genetically predisposed to a lower glycan age. I would love to believe it's a better test than the epigenetic test. Like, that's the real biological age test, but I don't have any great reason to believe that.
And if their claim about the inflammatory state, that would mean that it would reflect a lower inflammatory state, if that's right.
That's right. I mean, that is certainly what the claim is. People are developing inflammation clocks that measure different types of cytokines and inflammatory molecules. And so it would be interesting to see how well do the epigenetic clocks, glycan age, the inflammatory clocks line up. That's actually, so we also offer this test as part of the Optispan suite of tests that we offer. Again, we really do 3 what I would call biological age assessments. There's the epigenetic age test, there's the glycan age test, and we do the Sapir Bio, which is an immune function and aging test
based on like hematology.
That's actually based. So that's actually based on cell sorting. So it looks at some senescence markers, T cell activation markers, T cell inhibition markers, and autophagy markers. And we did an episode with Natalia Mitten, who's the CEO of Sapir Bio. So I should say, like, I think each of these tests give you different information. We have better information, in my view, about the Sapir Bio test because that's been paired with other clinical data outside of what we're doing at Optispan. One of the reasons why we're doing 3 different biological age assessments is we are pairing that information with the other data that we are gathering on the clients, such as we've already talked about, things like VO2 max, muscle function, body composition, blood-based biomarkers, imaging, right? So trying to get a picture so we can ask the question, to what extent does the information from these biological aging assessments line up or not with the other types of data that we're getting? And
do you see clusters where one test is showing more information about inflammation or hormones or some other?
Right. And we do look at a pretty, at least relative to clinics that are out there now, a pretty comprehensive inflammatory panel that goes beyond kind of the basic CRP.
What does Optispan measure in terms of inflammatory work in this space?
Yeah. So a few different things. I think the one that I'm most intrigued by is there are a few different panels of markers that diagnostic companies like LabCorp will offer that are meant to be diagnostic for different types of autoimmune disorders. And so we offer a few of those as part of our standard panel. The question, so those reference ranges are going to be built for clinical diagnosis of an autoimmune disorder. The question we're interested in is, will we be able to identify patterns within the reference range that line up with other biomarkers to predict people who either might have a intrinsic high chronic inflammatory status or are on the path to a clinical diagnosis of autoimmunity. And again, talked about this on the podcast before, but worth, I think, re-emphasizing is that, in my view, at least to some extent, biological aging is an acquired autoimmune disorder. And I know some people will get triggered by that, but what I mean by that is we know there's an increase in chronic sterile inflammation with age, and a big chunk of that is the immune system inappropriately responding to signals that it shouldn't respond to, and it doesn't respond to when we're younger. And that's what we call autoimmunity. It's your immune system responding to self. So we see an increase in clinical autoimmune disorders with age. And I think most people have subclinical autoimmunity that increases with age. And that's what we call inflammaging.
Do you have a sense of how much of chronic inflammation or chronic sterile inflammation is this autoimmune responsive versus just like increased general noise from the system not working as well, or reduced homeostasis?
I mean, I don't, because I mean I have a guess, but I'm not an immunologist, so it's just it's a guess. What I can say is we know from the literature there's evidence that you can have multiple types of damage that tie back to the hallmarks of aging driving this inflammaging, right? So mitochondrial dysfunction, mitochondria burst, you get mitochondrial DNA that then can trigger an immune response. DNA damage can trigger an immune response, the C-gas sting pathway. Leaky gut, right? So microbial antigens getting into circulation, triggering an immune response. Or the gut is actually the largest, I think, immune organ in the body. Oral dysregulation of the oral microbiome. So there's multiple paths by which you can get increased chronic inflammation, and what is most prevalent in which individuals as we get older, I think, is a super interesting question. And again, just to kind of add a little bit of context, this is why I think rapamycin seems to be particularly beneficial for some people, but probably not everybody, is for reasons I don't understand completely. Rapamycin seems pretty good at knocking down the chronic inflammation that goes along with aging without, at the same level, broadly impairing immune function and maybe even increasing antiviral immune function.
That makes sense.
Okay, so anyways, I mean, all in all, like, do you have any take-homes that you first personally got from these, or do you have anything that you would want to say to people out there who are thinking about epigenetic tests, Glycan age, other things that they could do?
It was an interesting experiment. If you're taking these, I think it's clear from the variability in your tests and the differences between the two that you have to take all of these with a huge caveat that we don't really understand what they mean in terms of biological aging, and it's not clear what you should or could do to alter them if you wanted to at this point.
Yeah. So I guess the last question is, did you use either of these tests to modify anything that you're currently doing? Did they influence any of your decisions, lifestyle, medications, whatever? And would you pay your own money to take these tests again in 6 months? And if so, why?
So they have not modified anything that I do. I would be interested in seeing kind of change over time and maybe something about variability. But as far as like out-of-pocket expense, they're still a little expensive. So I don't know if it's at the point where I'm going to do that with my own money at this point. So.
Fair enough. All right. Thanks, George. This has been super fun. Hopefully you guys found it entertaining and informative as well. As always, any comments or questions, please feel free to leave them in the comments section. And we hope to see you next time on the Optispan Podcast.